Looking back at the presentation until the last week, we looked at the Louis Vuitton Foundation again and thought about how the building was constructed. The LVF, built on the foundation of the building, has a very complex shape on the surface. In fact, the complex geometry represented by sail and iceberg was a significant challenge for engineers. By the way, what about the inside of the Louis Vuitton Foundation? Let's go inside the building from now on. The space inside the building is interestingly linear. If you look at the spaces of the building, it is as follows. The spaces inside the building, including 11 galleries, consist of a series of rectangular rooms at the center of the plane. This was a user's request, and despite Frank Gehry's strong design inclination, it has a fairly simple form. As we developed 3D models of Louis Vuitton Foundation, analyzed the construction of the building, we found that there are few columns in the interior space, including the galleries. One of the galleries has a height of 21 meters. This is in contrast to the fact that the structure outside the building is supported through numerous structural members. Since the Gallery of the Art Museum is a place where the continuity of the work should be maintained, and it has a great influence of the eyes of visitors, so we thought it was the result of the architect's intention and the engineer's efforts to remove the column inside the building. In order to figure out how did they build the structure, we studied various cases and guessed how the engineers could construct the interior of the Louis Vuitton Foundation without using columns. In general, a method that does not use columns is a wall column structure. The wall column structure refers to a structure in which the frame is made of a wall and is generally used in detached houses or apartment houses in South Korea. The vertical load is transferred from the slab to the wall, and the wall is transferred based on the vertical load while resisting the compressive stress. The horizontal load is transferred to the shear wall by the slab, and the entire building acts like a cantilever extending from the foundation and resists the horizontal load. In the case of a wall column structure, the sound of the floor is transmitted through the wall to the surrounding spaces. In other words, it is vulnerable to the noise because the contact point with the floor that causes vibration is wide connected to all walls. This is compared to the beam and column structure that supports the building by using columns. It refers to a form in which the frame is composed of columns and beams. In the case of the beam and column structure, vibration is dispersed to the beams and columns, and it reduces the possibility of floor impact transmission to the columns, which is relatively advantageous for the noise prevention. It is presumed that the concept of a wall column structure was basically applied when constructing the interior of the Louis Vuitton Foundation. However, unlike ordinary buildings, the Louis Vuitton Foundation had 11 galleries and an auditorium which is available as concert halls. So, using only the typical wall structure would not have achieved the required sound insulation performance. Engineers solved noise-related problems by using the floating floor system, which was presented last week. Without using an additional mold, an air layer was made between slabs by using a spring system to block noise from the surrounding spaces. However, this alone would not have solved all the problems. The shape of the interior of the building is not that special, but the size of the space is much larger than that of ordinary buildings. So, we investigated how this large space could have been constructed without columns, so that we studied the structure of DDP, which is similar to Louis Vuitton foundation for use. In the case of DDP, you can see that there is no column in the large space inside as follows. It is like a half-sized soccer field floating in the air, covering 85,000 square meters. How could such a large space be constructed without a column? Engineers of DDP used space frames, and we thought that Louis Vuitton Foundation also used space frames for construction. In architectural design, a space framing or space frame system is a truss-like, lightweight, rigid structure manufactured from interlocking struts in a geometric pattern. The components of the space frame are as follows. Space frame structures can be utilized for large areas with few interior supports. 3 members are connected to the triangular truss joint in the shape of an extra triangular pyramid, and the joint of the member consists of a rotating end like a truss. If the space is constructed in this way, the space frame can correspond to any shape. That is one of the reasons why we thought that space frame was used for the construction of Louis Vuitton Foundation. It is assumed that the interior space of the Louis Vuitton Foundation is not as large as the DDP, and it is not a complex shape unlike the exterior of the building. So, there would have been no major difficulties for the temporary construction. We guessed that engineers pre-made the space frame required for the building in the factory, assembled it in the field, and constructed it by using the lift-up method. Lift-up method refers to a method of lifting and installing a large structure to a high position after manufacturing it on the ground or below. This method is much safer because workers don't have to work on the structure high, and it can reduce unnecessary temporary space. Therefore, it is more reasonable for the construction period and construction cost than other methods. So far, we have studied the composition of the Louis Vuitton Foundation building and the 3D model, and investigated how the interior was constructed. Engineers were able to meet both the design of the building and the performance required for the user's comfort through the series of processes described today. The interior space constructed in this way is surrounded by the iceberg and serves as a structural core of the Louis Vuitton Foundation. It supports the sail part, which was the most challenging part for engineers. The resulting glass building takes the form of sailboat sails inflated by the wind. The glass sails are made of 3,584 laminated glass panels, each unique and specifically curved to fit the shapes drawn by Frank Gehry. The glass covering is made up of quadrangular curved panels, each geometrically unique. That was interesting for the engineers, because it is rarely seen in buildings and is more aligned with the scale of civil engineering or infrastructure projects. Of course, the use of beam was essential, and numerous construction methods were used to realize it. In the final presentation, we are gonna deal with these engineering issues. This is the end of today's presentation. Thank you for watching.